So I'm going to talk to you about some of our research on language intervention that we've developed that I'm really excited about, and probably I wouldn't have been doing if I hadn't been at the Mind Institute and really had kind of the motivation and also the expertise around me to allow us to do these interventions. So just a few disclosures that you can see there. I'm going to focus on Fragile X syndrome, which is the leading inherited cause of intellectual disability, and it really, as most of you probably know, it's caused by an alteration or mutation in a single gene on the X chromosome. And there's also a lesser alteration, which is called the premutation, which will be important as we go forward as well. And you're going to hear a lot more about this from Randi, who really is the world's leading expert on Fragile X syndrome. In addition to intellectual disability, people with Fragile X syndrome have a variety of other challenges, particularly things that are kind of challenging behaviors. And then the individuals who are carriers of the premutation also have a number of unique conditions, but the things that are most relevant right now are that many women who carry the premutation are at heightened risk for having anxiety and depression. So if you put all of that together very briefly, then individuals with Fragile X syndrome have really complex problems that need to be treated to support optimal development. And families may be challenged to really provide the optimal solutions to support development for their individuals, partly because of the challenging behaviors of the kids, but also because they're dealing with a whole host of other conditions themselves, which makes it even more difficult. And then the other thing that I think is important to know, and you'll hear, I think, about medications from Randi. Right now, medications are very helpful, but they certainly are not a cure for Fragile X syndrome. And so we need other things to really help kids and families. And so we want to figure out how to help families help their sons and daughters with Fragile X syndrome. And so we've been working on what we call parent-implemented interventions. You can really think of that as really trying to really turn parents into clinicians so that they have tools so they can actually essentially do therapies with their children. And so that's what I'm going to talk to you about today, these parent-implemented interventions. So our acronym that we use is PILI, for Parent-Implemented Language Intervention. And what we really kind of start with that in terms of the foundation is that the ways in which caregivers, including parents, interact with and talk to children really shapes language development. And that's true for typically developing children. And it turns out from a lot of research that we've done and other people have done that the same things that work for typically developing children work for children that are having atypical development, children with a variety of problems. It's just harder to engage in those activities, and sometimes you have to be more systematic at doing it. But really the same things work. And so our whole approach is really trying to teach parents to optimize their interactions with their children and then to optimize the input that they provide about language to their children. And so kind of the unique feature of what we've tried to do is that to the extent possible, we really deliver the intervention to the parent in the home through video teleconferencing and a variety of other digital technologies. So we basically use Skype so that we can teach parents in their homes in real time. And there are a number of advantages to that. The first thing is it really decreases the burden on family. They don't have to travel, and so they can be home to do these interventions. It really supports generalization, which is a real problem when we do a lot of clinical work, that there are many things that we can do in the clinic, but if they don't translate to the real world of the child, they're essentially useless, right? And so it really helps if you're doing this in the home and you're impacting behavior in the home, you have a better chance of getting generalization. It's cost effective. And it really increases accessibility for all families. Okay, our goal, many times we've had families who want to participate in our research at the Mind Institute, but they can't travel. Their children really have challenging behaviors. Travel becomes difficult, particularly if they have to get on a plane to do that. And so this really does increase accessibility. So the couple of things that I just want to mention about this, and I'm going to show you what the language intervention is, as PILI is, but the real work of the intervention is not when we work with the parent. The idea is the real work of the intervention is when we're gone and the parent has these tools and they work with their children in lots and lots of different interactions. And so the idea here is that there really is no limit to how much intervention the child can receive if the parents can do this. And then the other thing I want to say is that we don't see this as kind of a substitute for working with a speech-language clinician or other therapists at all. This is really a complement to that. So if you have a therapist working directly with the child and parents can kind of support that through their own efforts, then you're really going to optimize development for the child. And then the other thing that I'll say is that we're focusing really on the language part of it. When we started to do this, I was really naive about how you do interventions, and so I had all these wonderful strategies of supporting language, and the first time we tried it, the kid ran away, right? And so, well, you can't really do a language intervention if you can't get the kids engaged, and so you have to have strategies for pulling children in, keeping them engaged, dealing with challenging behaviors, hopefully preventing challenging behaviors, and that's really critical as well. And so we always work not with just SLPs, but BCBAs as well, and that's really an important part of what we do. In terms of kind of the common elements of the intervention, the idea is to really help parents be verbally responsive, and that really supports child language learning. And what we mean by verbally responsive language is it's language that follows the child's lead. So the interaction really is directed by the child. You as the adult kind of go along where the child is interested. You are affectively positive, so that you really keep the child happy and engaged. You respond contingently, so you talk about things that make sense based on what the child is doing. You include developmentally appropriate examples of language, and so you say things that are maybe a little more sophisticated than the child can handle, but not all that sophisticated. And then you encourage child communication. If the child doesn't have a reason to communicate, there's nothing to work with, and so you have to kind of figure out how you can do that. And again, it turns out it's difficult for parents of children with atypical development sometimes to be verbally responsive because of all of these other challenging behaviors that get in the way. These are amazing parents. They have not caused their child's problems, but it's just hard to do the things that are going to be optimal, and we help them do that. So I'm going to give you examples of two studies that we've done. One is with very young children, one is with adolescents. And I'll just tell you a little bit, and there's going to be some data, and if we have time, I'll show you some videos. And so we really, in this first study, which is with preschoolers, we're asking two questions. Can we really teach the moms these strategies? So do we see their behavior change in ways that make sense relative to what we're trying to get them to do? And importantly, does the intervention result in changes in the child? Does the child's communication improve? So you don't have to look at all of this, but just in terms of the ages of the kids, these are basically 2 to 3-year-olds with Fragile X syndrome, all have intellectual disabilities. These are kids with either no language or maybe just a few words. And here's the structure of this first intervention. So they come into the clinic at the beginning in this particular study, and we do kind of a pre-treatment assessment of the mom and of the child. And then in this study, this is a mix of kind of Skype and in-clinic visits. And so they would come in once a month to the clinic, and we would do parent education. So we have these videos and kind of didactic PowerPoint presentations that talk to them about verbally responsive language, how they can do it, the sorts of strategies they can engage in to prevent challenging behavior and the like. And then they're coached as they interact with their child. And so there's an SLP that's basically giving them advice as they actually interact with their child. And this was really the heart of the interventions, and then there are these weekly distance coaching sessions. So in the home, basically, the parent has a laptop that we've given them. They set it up, it has a camera, and then at a predetermined time, we Skype with them, and we watch what they do, and we tell them how they're doing, and we give them advice as they're interacting with their child in real time. The other thing is then we would also kind of collect data on how things were going without coaching, so we can see how they're doing and how the child is doing. We also, and I won't talk about this, but this is also really important, we would ask parents, what's a routine which is really difficult for you, and then we're going to help you with that routine so it goes more smoothly so that you can embed language in that. And I'll just give you one example of why that's important. So much language for typically developing children is learned in routine situations that kind of happen the same way over and over again. How many of you has your child had like a book they preferred, and you had to read the same book over and over again, and you can't skip a page, right? But there are other routines like getting dressed in the morning, taking a bath. Those are all things that typically, those are opportunities to infuse lots of language. If your child is difficult during those times, you just want to get through it as quickly as possible. And so we worked with parents on routines like brushing your teeth, getting a bath, getting dressed in the morning, and those sorts of things. And we help them to kind of make those go smoother and then to give the good language in between. And then at the end of the assessment, at the end of the intervention, we did a post-treatment assessment, and then we also had a kind of a follow-up. And so we did this as kind of a single study design, and I'm not going to present the data in that way, but I just want to give you a sense of what we saw. And so if you look at the top line, the follow and commenting, that's one of the things that we taught the parents. So basically to talk about what the child is doing. And if you look at the baseline, before we introduced the intervention, parents didn't do that very often. They did it over twice as much after the intervention started. In terms of prompting communication, they improved there as well, and that their contingent verbal responses increased from baseline to intervention as well. So basically, on average, and these were all moms, these were all biological moms, they really learned these strategies and changed their behavior as they interacted with their children. And then importantly, the children communicated more, which was really critical for us, because these were kids that didn't communicate that often, and they communicated when prompted more often, and importantly, they initiated communication even when not prompted. And so we really changed the children's behaviors in ways that we thought were important.
Look what I have. Look what I have. What is this?
So basically what you see here is that, first of all, you can look and see that this is before we started the intervention. The mom and the child aren't even facing each other, right? And they're playing with different objects, and there was not much language going on. And you can't really tell, but the mom's not really enjoying this at all. It's really not a good interaction, right? So the next one is kind of later in the intervention.
Take all trucks out.
Oh, more puzzle.
More puzzle. More puzzle.
Nice. Very nice having your hands ready.
Bulldozer. Bulldozer in. In. Bulldozer in. Big yellow. Yellow loader.
Good. Great pace today, and you're really emphasizing a lot of sounds in your words.
Bulldozer.
Go, bulldozer.
Bulldozer. He's waiting for me to say the word before he puts it in.
Oh.
So cute. Bulldozer. Blue truck. Red truck. Blue truck cement mixer.
Very nice choice. You can take a turn, too.
Mommy wants red truck.
All right, so the first thing you can see, I hope, is that they are facing each other, right? And so what you can't see is that they're focused on the same object, they're talking about the same object, there's a lot more talk from the mom, a lot more responsiveness from the child, and it's a really positive interaction. And I think that what impressed us the most is, I think one of the things that gives us the most hope is the fact that these interactions are so much more positive, and that when we did exit interviews with the moms, they all said, I feel closer to my child. And I think that is so critical, because that will hopefully keep that going. As we went forward, one of the things that we heard a lot from parents was, we would do these presentations about these 2- and 3-year-olds, and we'd have parents of older kids going, there is nothing for my teenager. There is nothing, and we don't get enough speech and language services in the schools. Can you help us? And so we worked to develop this intervention, which is kind of based on the same principles, but it's a more age-appropriate version of this. And so we're really asking the same thing with an additional question here. So these are adolescents, and we wanted to say, could the moms learn the strategies? Did we change the child's language in this instance? And were the interactions that they had more sustained? Because the other thing that parents would say is, we don't really have interactions other than kind of for a few turns, and then he's gone. I just can't really interact with him. And so the context that we used was interactive storytelling. And so we basically gave parents wordless picture books that we had digitized and put on iPads, and we gave each parent an iPad with lots of different stories on. And that became kind of the topic of conversation, the focus of the interaction. It wasn't play-based like it was appropriate for 2- to 3-year-olds, but for 10, 12, and 16-year-olds, you need to have something appropriate. And books, we felt, were appropriate. And so the idea was the parent and child would look at the book together. We gave the parent a script to kind of guide them a little bit about how to introduce the story. And then the idea was we gave them very specific strategies for introducing language and pulling for communication and the like. And the idea was that was a way to to get the child sustained in the interaction, and also to introduce new vocabulary, new grammar, so the child could learn more, okay? And then the idea was is they would have a book that they would do for a week. The idea was is as you went through the book more, the child could learn more and kind of take on more of the ownership and more of the storytelling, and then they'd switch to a different book the next week and so on, so they had a lot of different books. And the thing that was different here is we did all of this through Skype. So there were no clinic visits other than at the beginning and the end that we did the assessment. The entire intervention was delivered through Skype. And so they had 2 parent education sessions to kind of introduce the strategies. Then we had weekly coaching sessions, and now we got sophisticated, so there was a bug in the ear. And so the parent could hear us as we coached them as they interacted with the child in real time, and the child couldn't hear us. And then we had a homework session so that they would do this without us there, send us a video. We would look at it, schedule a Skype call with them, and then we would review the things that they did well, things they needed to work on, and the like. And then we collected data without us intervening. And so this is single subject data, and so just really quickly so you can see this. So the kind of the black line shows on that side of it is before the intervention started, and then after the intervention started on a weekly basis, and these are for the individual children and their moms. And what you can see is that the amount of talk about the stories increased dramatically, something like between about 7 and 10 utterances each of them made about the story. And you can see they went up to about 150 to 200 turns each. So they really got engaged in the story as a result of the intervention. The moms used WH questions, which are a really good tool, which we taught them to do, and that increased pretty dramatically for all 3 of the moms in this study. For the use of expansion, so taking what the child says and saying it in a more mature form, that increased as well for all 3 moms. We also had them do these fill in the blanks. Those were things like, the boy went to the, that didn't work quite as well, but the moms increased a little bit there. And then importantly, if you look over here, this NDW, it's a number of different words. And so that's really important because this is the child, and they ended up going from about using 50 different words before the intervention to using, in some cases, 150 different words in these sessions. So they really learned new vocabulary, and then they used more of the vocabulary that they had. MLU was a measure of grammar that improved for 2 of the kids, the 2 bottom ones, and not for the first child, and we think for some reasons we understand well. Let me just end with kind of a few things. So we feel like this is really the way to go. You reduce the burden on families, you increase generalization. It's really cost effective to do this through distance. There are things that we would do differently, we want to develop. We really want to figure out ways of measuring how frequently the parents are using these things kind of outside of our view, because again, that's where the real action is. We need to do more to help parents support generalization of these skills. There are lots of other new technologies that we're looking at and we think we can do. And the other thing is I think what's really going to be critical is to figure out what's the intervention that the parent has, that the speech-language clinicians is doing, and then we can adapt the intervention to fix that. And then the other thing, and we're doing this in 2 really large-scale studies now, is we think we should combine this with medications, because then we can have synergistic effects. And so we're very excited about this. Families love this intervention, and they stay with it for the most part.
My name is Randi Hagerman, and my goal is to cure Fragile X syndrome, and actually in the process of doing that, we think we can cure many forms of autism. And that's because the protein that's missing in Fragile X actually is a control protein, and about 40% of all the different proteins associated or mutated in autism are controlled by the Fragile X protein, FMRP. So as Len already explained, individuals with Fragile X syndrome have a lack of this protein. In girls, of course, there's more protein available from their other X chromosome. In those who are carriers, they actually produce too much messenger RNA, which causes toxicity, and that's how you get early menopause or primary ovarian insufficiency, depression, anxiety, ADHD, sometimes it even causes autism, and then this aging syndrome with tremor and ataxia called FAXTAS. Now, it is very complicated. The medications that we use to reverse the neurobiological abnormalities in the brain are many. And I apologize for the complexity, but when the Fragile X protein is missing, there's upregulation, because the Fragile X protein is usually an inhibitor. And so there's upregulation of this mGluR5 pathway, this MEK-ERK downstream pathway, because this pathway leads to weak synaptic connections. So if you can block the upregulation of this pathway, the thought was you could cure Fragile X syndrome. And that's when people got all excited. They were trying all these antagonists, and we'll talk for a moment about that. But then also the GABA pathway, the inhibitory pathway, is downregulated in Fragile X syndrome. So we want to increase this GABA or inhibitory pathway so that they are less anxious, less hyperactive, less impulsive. And for those of you who have worked with Fragile X kids or kids with autism, because kids with autism have this GABA or inhibitory deficit, then you know how it can play out in behavior. And then there's many other medications that we're looking at, so I'm just going to give you a little survey. Now, lovastatin downregulates this MEK-ERK pathway, and that's the one that we're combining with PILI that Len just talked about with the parent-implemented language intervention. So if we can work together with the medical interventions together with the educational interventions, we'll get a synergistic effect and really make a difference in the development of these children. Now, the FDA, who controls all the medications we use, have this idea that you have to show benefit in adults before you can go down to children. And in fact, these mGluR5 antagonists from Novartis and Roche were tried first in adolescents and adults, and it didn't cure the intellectual disability or the behavior problems. Because sometimes when you get smarter, your behavior, as you're more aware of things, sometimes can get worse, okay? And what we learned from these trials is, hey, you gotta start younger. You gotta start younger with these medications, because in the safety studies, when we used AFQ-056 for like 3- and 4-year-olds who weren't talking, boom, they started talking, okay? So now we're working in a multi-center trial. It's called the Fragile X Learn trial, where we combine Len's PILI intervention, kind of a different form of PILI, together with this medication. Sometimes it's part of a controlled trial, and sometimes they're on the medication for sure. So again, it's a synergistic intervention with language, but also testing and seeing where this medication can really make a difference. So this is for 3- to 6-year-olds with Fragile X syndrome, and we will start enrolling hopefully next month, and 14 centers throughout the U.S. will be enrolling. So we think we can make a big difference. One of the medications that we looked at is Sertraline. It's an SSRI, which means selective serotonin reuptake blocker, because it allows more serotonin to stay in the synapse. And we know in kids with autism, the amount of serotonin in the synapse, particularly in young kids, is too low. So when an SSRI was tested in older kids with autism, it wasn't too effective, or it was just effective for a subgroup. But when we used sertraline, and I mean low dose, like just 2.5 milligrams, in young kids, our preliminary studies saw an improvement. Like here's expressive language trajectory from the Mullen on sertraline. This is not on sertraline. This is receptive language on sertraline. This is not on sertraline. And so we did a controlled trial of kids 2 to 6 with Fragile X syndrome lasting 6 months on low-dose sertraline. And guess what? All kinds of things improved. These are months of improvement on sertraline compared to placebo, and several of these things were significant, not only benefits in the overall cognitive score, but visual perception, fine motor improved. We saw some improvement in language, but it was only those kids with autism and Fragile X syndrome that had a significant improvement in expressive language on low-dose sertraline. So now we're doing a controlled trial with young kids with autism, idiopathic autism, ages 2 to 6, and it's low-dose sertraline, and we're enrolling until October. So if you have a young child with autism and you want them on this controlled trial, you have until October to get them in. So we hope to see them. We have used GABA agonists. One is ganaxolone, and our paper is coming out in November in Journal of Neurodevelopmental Disorders. And overall, we didn't see an improvement overall on this ganaxolone, this GABA agonist. It wasn't that much difference compared to placebo. But when you look at the kids that had high anxiety, that's when you saw improvement on both the visual analog scale for anxiety, they improved, and also on the Adams scale, they improved when they were on ganaxolone. So there probably will be future studies looking at the ones that are most anxious. Again, this is the lovastatin with PILI study, and we are still enrolling. So if you have any kids with Fragile X between the ages of 10 and 18, they get to do the PILI. And remember, lovastatin downregulates this RAS MEK-ERK pathway, so it lowers the excessive protein synthesis in Fragile X syndrome that causes the weak synaptic connections. So we think that this will work well with the PILI. And again, 10 to 18-year-olds, and we've got plenty of room. Now I want to talk about a new targeted treatment called Metformin. Now many of you know about Metformin because it's a type 2 diabetes medication. It also helps individuals who are overweight. I'm even thinking about going on Metformin, okay? But the really exciting thing, it's helped other disorders like Prader-Willi, phenotype of Fragile X. These are individuals that have massive obesity and way too much overeating, and that's about 10% of those with Fragile X. It has cured the fly model for Fragile X and the mouse model for Fragile X. And actually, the more I read about Metformin, the more I like it. It impacts all different pathways. It lowers this MEK-ERK pathway. People on Metformin live longer than people not on Metformin. And guess what? It's cancer protective because this MEK-ERK pathway and some of the mTOR pathways lead to proteins that stimulate growth in cancer. So if you want to have less cancer, live longer, and be thinner. And so we're testing this out in Fragile X syndrome ages 6 to 40. We've tried it in an open label in several patients, and guess what? They can talk better. They're able to carry out two-way conversations when they couldn't before, and there's improvement in behavior. So we're really excited that Metformin might help with cognition. Eventually, we want to go down to younger ages, 2 and older, because we've seen anecdotally some very exciting things with young kids with Fragile X. And I want to say that to be able to do this clinical trials program at the Mind Institute, it takes a lot of effort, many coordinators, many great people, Len, David Hessel, Susan Rivera, many other people at the Mind Institute help us with this, along with our collaborations around the world. We do a lot of international training. In fact, I'm writing a grant today about developing the infrastructure in the Philippines, in Colombia, South America, and in Indonesia to carry out clinical trials. So we're very excited about disseminating what we do at the Mind to international locations. I want to cure Fragile X because I can't retire until I do. And so we are definitely motivated.
Good morning, everyone. I'm Julie Schweitzer, and I direct what we now call the Attention, Impulsivity, and Regulation Program, or AIR. And primarily what we study is ADHD. So how many people here work with children who have ADHD? If you could raise your hand. Okay. Now, how many people here work with children who have a neurodevelopmental disorder who also have ADHD? Okay, I suspect there's many more than that because as you just heard, Fragile X also has ADHD, so does autism and so forth. So we're going to talk a lot about the more pure ADHD, what we study in our lab, but we're also doing a lot of research more recently looking at ADHD symptoms in children with autism and other disorders, including Fragile X. So I'm receiving some funding from NIH, other sources, but this does not influence my presentation today. I'm particularly interested in impulsivity. And we have a big project called MINT, Mapping Impulsivity's Neurodevelopmental Trajectory. And I'm interested in impulsivity because it's so impactful, whether it's in a child with autism or children with just ADHD or adults with ADHD as well, or people in general who maybe don't even have ADHD, but they're very impulsive. And so, for example, that could be somebody who a child sees a toy they want and they grab it from another child. That could have implications in terms of their social relationships. But nowadays, I keep thinking about social media. Somebody posts something on Instagram and they regret it later, right? Or they tweet something out and then you hear that they pulled their Twitter account. So we're in the age of impulsivity, I think, in many ways, and we can see the impact this has on us and in society. One of the ways that we study impulsivity is we use the universal reward, money. So we give people the option to choose between a small amount of money versus a larger amount of money later. And we have two different conditions we do that in. A decimal, where you see there's a decimal at the end, and here's a rounded number. And what we do, we give people a chance, we give half money trials with the decimal versus the rounded. And we do that with typically developing individuals as well as individuals with ADHD. And what you see here, these are the typically developing, and these are the individuals with ADHD. And for both of them, when it's a rounded number, they're more impulsive. So this is a measure called K, and the higher this is, the more impulsive they are. So overall, obviously, the ADHD are more impulsive, but on both of them, just making that small manipulation in how you present a question makes a difference. And we call this framing effects, and economists are very interested in this. So you have to think about how you present some information before somebody's making a choice. And there's another group of people who are very keen on how to do this, and they're called marketers, right? And they do a really good job with commercials and so forth, getting our attention. And I think that industry, they're very keen about how to do that, but we're thinking about how to use that as well for our clinical work, and maybe working with a parent to help them design a behavior program with their child to think about how they present different choices to their child. But just to show you can make a small modification in how you present a question, and that can impact choice. We also have this looking at brain activity as well, and it turns out the brain is much more active for the rounded condition, so it seems like those rounded number lead to greater impulsivity, maybe because it's easier to process in the brain. So this is a collaboration with Sam McClure, my colleague at Arizona State, and Wouter van der Bos, who's at the Max Planck in Germany. And we looked at a group of children between 12 all the way up to about age 30. The average age was about 16 years. And we looked at over time whether people became less impulsive or they became more self-controlled. And so by that I mean whether you gravitate towards something and you want it. So for me, it's always chocolate cake. That's my reference point. That's what I want. I see chocolate cake, I want it. Or am I able to think more about the future and think if I eat that chocolate cake, I'll eat maybe less for dinner, or I'll have to be at the gym longer. And so we looked at over how this related to age. And do people become, as I said, less drawn to the chocolate cake or whatever it might be for you? Or do they become more able to think about, yeah, do I really want to go to the gym tonight and work out and think about the future? And what it turns out, if you look at age over time, what happens is that impulsivity doesn't really change in a sense that you're not drawn any less as you mature, but what you are able to do is think about the future. So I think about this a lot with our teens. So when they're texting and chatting with their friends, are they able to think about really stopping texting because they're going to hurt their friends' feelings if they don't respond, which is more of an immediate response, or are they able to think, wow, if I'm texting, I'm not doing my homework. If I'm not doing my homework, that's going to affect my grades. And if it affects my grades, it's going to impact on my choices for college and so forth. So that's more forward thinking. What we see, there's not that big change in terms of the immediacy. What it is, that kids are better able to think about the future and how the future is going to impact their current behavior. And so it's the same thing when we did this by two ways. We used a Zimbardo time perspective inventory, which is a rating scale, and we also looked at their actual choices on that task I showed you before with money. And it turned out for both of those situations, whether it's the rating scale or actual behavior, that what changes with maturity is that people are able to think more about the future, and that's what changes increases their self-control. Now, this is in typical children. Right now, we're replicating the same thing in people with ADHD in our MINT project. So this is just to show you some of the other work in relationship to these issues in our lab. And this MINT project is a longitudinal study, and I'm pleased to announce that the National Institutes of Mental Health has decided to award us for 5 more years of funding. So we're able to follow these children over time, longitudinally from the ages, young adolescence all the way through young adulthood. But what we see is even within 1 year space of time, you can see here, these are the kids with ADHD, and these are the typically developing kids. And these are hyperactive symptoms, I think. Somebody's eyesight's better than mine. I think these are the inattentive ones here. But they both showed the same pattern, is that just even in the space of 1 year, these symptoms decrease in adolescence. No major change in the controls. And they're not decreasing to the level that the controls are, but you can see they're improving. And I can tell you, this is some of the most critical questions that parents present to us. They want to know, is their child going to outgrow ADHD? I can tell you that is on the foremost mind of many of our parents. And I can say for a lot of them, these symptoms will resolve. Not for all of them, though, and that's a major issue that we're trying to understand is for whom are those children, what children are those symptoms going to resolve, and can we predict that? But it's nice to see that it's decreasing over time. And so the other area we become very interested in relationship to impulsivity and just mental health functioning is emotional lability. Because what we're realizing is people, when they're impulsive, it's not just around decisions about whether to do homework. It's about how they're going to react to a situation and how emotional they're going to be. So if somebody has a slight toward them, can they let that go, or do they keep thinking about it? And do they have a hard time reining in their emotions, or do they get depressed and ruminate at it and so forth, or do they get anxious? So we're starting very much now to look at mental health and how that relates to ADHD symptoms. And again, what we see is that kids with ADHD, there is a much more emotional ability, but it does decrease in time. But what we're interested in is there's a group of people where it doesn't decrease over time, we're seeing. It stays the same. And our hypothesis is that for those people, those are the people who we really have to watch, because those are the people we really need to do some intervention and prevention work. Because ADHD is associated with a lot of negative outcomes, such as in young women, it's associated with a higher rate of suicidal ideation and suicidal intent. It's also associated with poor marital relationship functioning, more job changes, and so forth. And we think all of this relates. So if we can find those individuals at a higher risk for these worse outcomes, we'll think we'll do a better job in terms of intervening and helping protect them from worse challenges as they age. So again, for some of these people, it decreases over time. But the other area that we become really interested in is irritability, because that seems to be a very specific issue within emotional lability. And these were items that we got from the Connors rating scale at the suggestion of Ellen Liebenluft, who's our collaborator at National Institutes of Mental Health. And she was shown again, for people who have high irritability, their outcomes are likely even worse. And so, again, we'd love to see them all get to the point where they're more in the typically developing range. But this is who these group of people we're going to be following and looking at sex differences as well over time. Now we're changing gears a little to talk about intervention. This is a study that I did in graduate school, and that we're now trying to replicate with advanced technology. So in graduate school, I did something very similar to the marshmallow test. Raise your hand if you're familiar with the marshmallow test. Okay, a fair number of people. So the marshmallow test was something that Walter Mischel did out at Stanford, where he gave children the choice between one marshmallow. These are preschoolers. But they told them when they experimented left the room and they came back, they could have 2 marshmallows if they waited and they didn't eat that marshmallow. And if you're ever bored, you can go on YouTube and you can look at videos of marshmallow. And you'll see children licking the marshmallow, looking around to see if anybody's watching them, poking the marshmallow, and then occasionally somebody just eating the marshmallow, right? And so they followed those same children from preschool now 30 years later. And those marshmallow responses have been very predictive in terms of outcomes, in terms of body mass index, cardiac findings, academic success, drug use, and so forth. So what we've been trying to do is see if we can change that so we can increase one's ability to wait. And so what we do, in the old days when I first did the study, we gave children a choice between 1 sticker versus 3 stickers, or 1 M&M versus 3 M&Ms. Now, with advanced technology, it's a little bit of game playing on a tablet versus more game playing. So if they wait longer, they get to play more games, because game playing, I think, is more universal than marshmallows nowadays. And essentially what we do is we teach them to wait. And I actually mirror this after an animal study. So this was a study done with pigeons years ago. This is before we coined the term translational research, but it was a translational study, because I saw the pigeons learn to wait if you just gradually increase how long they needed to wait. And so that's what we did with children. This is what this study is in 1988. We saw before they had the intervention, most of them weren't willing to wait more than 5 seconds. But after forcing them to wait for a little while, some of them went up to 5 minutes, okay. Some of them went up to over a minute, one even up to 90 seconds. So we're trying to replicate that on a much wider scale. Our long-term goal is to then maybe have this app that parents can use at home, or driving the car. If they're going someplace, to give the child a game to play with, and lo and behold, they're actually teaching them some self-control. Seems to be a lot of interest in fidget spinners, and I hate to say this, but unfortunately I think our lab may have had something to do with this inadvertently. So we published a study a couple years ago, and this is typically developing kids and kids with ADHD. These kids were an actigraph on their ankles. It measured movement, amount of movement, and thrust of movement, and we found that when kids were moving more, the kids with ADHD, this is accuracy, they did better on this attention test, whereas the typically developing children, the movement didn't relate to that. So somehow somebody made the leap, and I wish it had been me in some sense, that if you take that data, you should buy a bunch of toys. And so we've been quoted a lot, all over the world actually, for saying that fidget spinners can cure ADHD. I have never said that. Never said that. But my name and my picture has shown up actually on websites as if I'm endorsing products. I have not done that. But we are working on looking at this with a colleague at UC Santa Cruz to see if we can find out if we can direct fidgeting in a certain way, whether it can be helpful instead of being really distracting like it is in many of the classrooms nowadays. So another project that we were launching is we called VRAM, Virtual Reality Attention Management. And this is where we're cutting out the middle woman, where we're trying to treat distractibility at home. Kids will use a Samsung Gear headset and phone, and they'll be practicing in a virtual classroom, and by cutting out the middleman, because I was describing in our class the other day about how if you can demonstrate you have a high rate of distractibility and you can get this training at home, similar to what Dr. Abbeduto was saying, you don't necessarily need to go to a pediatrician or a psychiatrist. You could get this treatment maybe someday just at the App Store. And the way this works is that there's distractors in the classroom, like an airplane flying by or kids passing notes or a school bus going by, and children will be doing math tests and attention tests, and the idea is for them to learn to gradually ignore distractors and improve their attention on task. So this is from our colleague Skip Rizzo, a classroom he designed in the, I think, early 1990s. Now the software is much more sophisticated. So this almost looks more like a photograph to me, that just because the graphics have become so much better. But our classroom's going to look much more real. And then we are also, Randi, the great reminder, we are also recruiting subjects, so between the ages of 8 to 12, to participate in this project. So in terms of future directions, as you can see, I do research in many different areas, from neuroscience research to intervention research. And the real disconnect for many, many years in ADHD research is that those have not come together. So almost every intervention in ADHD has been completely divorced from the research in neuroscience. And what we're trying to do is bring our understanding of the brain and how it works and think about that in terms of designing our treatments. So that is a major goal of our lab. That also has to do with looking at subgroups, because ADHD is such a broad diagnosis. And yet, you know, if you've met one child with ADHD, you met one child with ADHD, right? They're very different. So if we can start figuring out specific patterns within these children and how they respond, then we think we can have smarter, more effective interventions. And what we're calling this now is precision medicine. And so that's our goal, is to really individualize what we're doing with them. But also, I'm very interested in development, and I think as people mature, what works at different ages is going to depend where they are in terms of their social, emotional, and physical development. So we're taking that into account. And the nice thing is about, we're now learning adolescence isn't necessarily a time just of anxiety for parents and risk, but it's also a time for new learning because there's so much great brain development that occurs in adolescence, and that we can harness that and look at how children in those teen years are learning, and then look at our interventions that are designed specifically for them. And so that's our long-term goal. Thank you.
Thank you all for being here today. I'm very honored to be presenting to this group here. The study that I lead at the Mind Institute is called the GAIN study. It's the Girls with Autism Imaging of Neurodevelopment study. And it really was an offshoot of the Autism Phenome Project, which I won't be talking about today, but some of you may have heard about that in past lectures here. The goal of the study is to really try to understand the neurobiology of sex differences in autism, and following on the precision medicine idea is because we think that if we can understand the etiology and the neurobiology in girls versus boys, there may be better pharmacological or different interventions that would be more suitable for girls as opposed to boys with autism. So giving a little background, one of the most consistent findings in all of autism research is this difference in the sex ratio of who gets diagnosed with autism. And so here's just a figure showing that even as the prevalence of autism overall has increased over the years, in the year 2000, it was 1 in 150 children being diagnosed with autism. And more recently, in 2008, it was up to 1 in 88, and even higher these days. That prevalence ratio of 4 boys being diagnosed for every 1 girl has remained very constant over this time. And so the big question facing us as researchers these days is why? Why are there so many fewer girls being diagnosed with autism? And that's really where the GAIN study was born. I'm giving you a lot of background on why we're doing this because the study is still ongoing, so I don't have a lot of results from my study yet to show you. Maybe next year or the year after, since the program is already planned for next year. But I want to go into 2 different prevailing theories right now as to why there are fewer girls being diagnosed with autism. And I keep saying why there are fewer girls being diagnosed as to why are there fewer girls, because one of these ideas is that perhaps using the diagnostic criteria that we have today, girls are simply going underdiagnosed with autism. And then the second is a biological theory that I'll talk about more in depth called the female protective effect, and I'll go into more detail in a few slides. The first, this gender bias in diagnosing autism, and this is a very tricky thing to study because at the Mind Institute, to enroll girls into the GAIN study, we need them to have a diagnosis of autism, and we're sort of limited by the diagnostic tools that we have. And the diagnostic tools that we have, the ADOS and the ADI, are the primary tools that we use, were really developed using large cohorts of boys with autism in those research studies. And so there's this growing notion that maybe those criteria aren't being applied the same, or they're being applied the same way in girls, but they're potentially missing some girls with autism. And so the study I want to highlight here was actually going beyond the clinical diagnosis. So this was a study carried out by Francesca Hoppe and her colleagues a few years ago. It's one of my favorite studies that got me into this field. And what she looked at was 15,000 twin pairs in the general population. All of these twins, all of these children at age 8 got an assessment of what their autism traits were. So they didn't necessarily have a clinical diagnosis, but they wanted to know from their parents how high are their autism traits. And then they looked and broke them into 2 categories. There were kids who had high autism traits but no clinical diagnosis. And then there were kids who had high autism traits with a clinical diagnosis. And then they looked across boys and girls to see what the differences were. And what they found was that girls, even girls with a clinical diagnosis, even though they had the same level of autism traits as the girls in the other group who didn't have a clinical diagnosis, the girls with the clinical diagnosis tended to have higher levels of intellectual disability or other behavioral challenges on top of that. So this leads to the idea that perhaps for a parent to bring their child in for a clinical diagnosis, or for them, the diagnostician, to give them a clinical diagnosis, they have to have other problems on top of the autism. And so this study really leads to this idea that perhaps girls are flying under the radar. They're less likely to receive the diagnosis of autism despite having the high autism traits unless there are additional problems. And this, of course, becomes important later as well because there's some evidence coming out from studies from colleagues at the Mind Institute that girls with autism, as they reach adolescence, have higher levels of mood disorders, depression, anxiety, So we really want to catch these girls and diagnose them correctly so that we can give them the services that they need. Another study I wanted to highlight was going with this idea of camouflaging. So another idea in the field right now is women are better at masking their symptoms of autism. This is called camouflaging, or another way to think about it is they have better coping strategies for their autism traits. And this is a study I wanted to highlight by some colleagues in the UK. Meng Chuan Lai has really led the field in studying gender differences in autism. And they simply did a clinical observation. These are now adults with autism. They did a clinical observation and then a self-report of autism traits. And what they found was that in the clinical observation, they exhibit less severe social communication deficits in the direct observation. But then on self-report, the females were actually rating themselves as more severely affected, leading to this idea that females are better at adapting or compensating for their actual deficits, masking their social deficits, and so that when they are actually in clinical or social situations, they don't seem as impaired as they really are. So moving on to the biological theory of why there are more females with autism, this is something called the female protective effect, and this has really guided a lot of the research that I'm doing right now. And it stems from this sort of complicated model shown here called the multifactorial liability model, which is a mouthful to say and sometimes a little bit complicated to understand. So I'm going to illustrate this with some pictures drawn by my daughter. Because it's more on, if I can explain it to her, then I can explain it to everybody else. But the main thing here is that we all have some sort of etiologic load. And here in my analogy, it's rocks. And so the rocks each represent some sort of genetic hit or environmental factor that contributes to an individual's risk for having autism. So you have this load and you have this threshold as well, what we call the liability threshold, such that when that load becomes too great, they cross this threshold, they drop their rocks, and they get a diagnosis of autism. And so the idea here is that here's a little boy, he has his rocks, and he has this etiologic load, and crosses the threshold into autism. But in a little girl, there's something protective about her. She has baskets. She can carry more of that etiologic load. She can carry more genetic and environmental hits before she crosses that threshold into autism. And one of the things that we're really interested in trying to understand is, what are those baskets? We don't know what those baskets are yet in our research. We think that some of those may be residing in the brain. There may be some areas in the brain that are compensatory or adapting in girls that are protecting them from having the diagnosis of autism, and then they cross that threshold when eventually that burden does become too great. So hopefully that was clear. Thanks to Clara, who's also the star of my brochure and all of my GAIN studies, and I think I have a picture of my son in here later too. Strong evidence for the female protective effect comes from genetic studies. And so a few years ago, there were a series of studies that came out that showed that girls with autism, as compared to boys with autism, actually have a greater number of genetic mutations, copy number variants, than do boys. And so this is going along with that idea of the girls have more rocks in their basket. They have more genetic burden before they've crossed over that threshold into autism. And following from that, since we know that many of these genes control brain function and synaptic development in some way, the parallel to that is perhaps there's also an increasing neuropathologic load in these girls with autism as well. So they may be showing more extreme neural abnormalities than boys, and maybe we can target some of these pathways. If we can identify them first, we can target some of these pathways for better interventions for girls that may not be working so well in boys if they don't actually have those deficits. Or we can work on those brain areas that are compensatory and make them stronger to help the girls deal with their symptoms. And so here's just a summary. Understanding the neurobiological differences between boys and girls, we're hoping could lead to more effective and individualized treatments and interventions. So there is some neurobiological support for the female protective effect. This is from a paper coming published just this year, and actually I'm happy to say the grad student who worked on this paper is joining my lab in January as a postdoc. But they had a large cohort of adults with autism, and They looked at their brain patterns, so they all had MRI scans, and they just looked at their brain structure. And they did a pattern classification, basically throwing in various measures of brain structure and saying, can you identify, asking this algorithm, who is a typically developing male versus a typically developing female? And sure enough, it could distinguish pretty well. The red on the left side is females, the blue is males. And it was pretty accurate at doing this. And if you can remember back to that graph I showed a couple of slides ago, this really pretty much mirrors what I was showing with those two curves of the females and the males. However, when they applied the same classification algorithm to individuals with autism, what they found was the females and the males didn't differentiate the way they did in typical development. The females with autism had actually shifted their curve to the right, just as we would have predicted in the multifactorial liability model, that the girls with autism with a diagnosis have shifted over to the right. There are several other studies that have shown regional differences in the neural alterations between males and females with autism. I'd highlight that most of these studies are done in older individuals, so adolescents and adults with autism. And of course, these individuals have had a lifetime of intervention and therapies and life that have just happened to them. So when we're studying the brain of individuals in adolescence and adulthood, it's hard to distinguish what's autism versus what's some sort of adaptation or what the brain has gone through as a result of all of these interventions and therapies. Our study is focused on very young kids because we want to try to study the neural deficits in autism as the symptoms of autism are emerging. But I'll just highlight a few of these studies here. Meng-Chuan Lai in 2013 really published the first landmark study showing that men and women with autism really had very different neuroanatomical patterns of brain structure. I published a study a few years ago. This is what actually led to the GAIN study, showing that boys and girls had different patterns of corpus callosum organization. So the corpus callosum is the larger fiber pathway that connects the right hemisphere to the left hemisphere. And I won't go into the details here, but basically, boys and girls had a different pattern in brain regions where the corpus callosum was connecting to social versus cognitive areas. There have also been studies looking at cortical thickness and gyrification, which is the pattern of folding in the brain. All of these have shown that boys and girls are different, or men and women are different in autism. And what this really tells you is if you run a study of people with autism, you can't lump boys and girls, men and women together because they really have distinct patterns of neural alterations. So the GAIN study, and this is my plug for recruitment now. We are now in the 4th year of our grant. When we started the grant, you can see the numbers from the Autism Phenome Project. I had 155 boys in the study and only 34 girls with autism in the study. And so I published a lot of papers on the boys, but I really felt like we were doing the parents and the families of girls an injustice because we just didn't have enough girls in our study to really tackle these questions and find the answers about what's different in their brains. And so the GAIN study was born. Our goal was to recruit 90 more girls with autism and then some controls as well. We enroll them at 2 to 3.5 years. They go through our comprehensive behavioral batteries, and we do an MRI scan at night, as Robin said, without sedation. I've lost a lot of sleep over the past decade, but it's all been worth it because we do all these scans at night at bedtime, and I have a slide showing that. We're about 2/3 of the way through our recruitment. It turns out that recruiting girls with autism at this young age is kind of difficult because there are fewer girls diagnosed with autism at this age. And some of the girls that come in actually don't end up meeting our criteria because it's just very tricky, I think, to diagnose girls this early. Let me go a little bit into the MRI scans because that's something a lot of people are a little bit worried about when they come into our study. And I think it's, I just want to, for those of you who've never or have had an MRI scan and may think it was kind of scary, we actually do it at the MRI center in a much more child-friendly way. So I work very closely with the parents. I get to know each individual child's sleep patterns, their routines, how they go to sleep, when they go to sleep, what loveys they need to go to sleep. Oftentimes it's mom or dad that's the lovey. And so we take our MRI scanner and we basically make it more child-friendly by putting beds on either side. The parents can get up and lie down with their child, have them fall asleep, and then we sort of tear off all the sheets and we send the child into the MRI scanner. and a lot of them sleep through it. We've scanned 365 kids, 2 3-year-olds during natural sleep, and it works way better. And every single time it happens, I'm shocked because I could never sleep through an MRI scan. But little kids, they play hard and they crash hard, and so we really can do it. We send them home with a practice kit so they can put earplugs and headphones, and so that's my son showing that picture. I can say, when I talk to the parents, my daughter, I was able to scan. She's actually a control participant in the GAIN study, so in addition to illustrating my talks, I make her participate in my research as well. But she's now 11, so she's had 4 MRI scans through the study. And so I tell parents, you know, it's possible, but it doesn't work in every child. So here's my son when we tried to do an MRI scan in him, and it didn't work. So it works in most kids. It doesn't work in all kids. It works in about 90% of the kids that we try, though, so it's pretty phenomenal. And then we stay with the kids the entire time during the MRI scan in case they wake up, and the parents can actually stay in the room as well. So we're working on trying to identify more neurobiological patterns that are different in these younger kids with autism. So just in summary, using our current diagnostic practices, some girls may be flying under the radar, may be going under or misdiagnosed. There's evidence from recent genetic and neurobiological studies for this idea of a female protective effect. And lots of, well, not a handful of studies, really under 10, have shown that males and females with autism have different patterns of brain alterations. What we need moving forward is more females in research studies, particularly in younger children. And all of this, again, is to try to understand the biology, because we think that sex-specific pharmacologic treatments may be necessary. So I'm really, you know, we've heard a lot about pharmacologic treatments, and young boys and young girls develop very differently. Girls are smaller oftentimes, and so if we're just doing our research based on boys and we're identifying, you know, the right pharmacologic treatments in boys, they may not be the right ones for girls, and that's a big concern for me. And as well, specific interventions for boys or girls. So lots of people have helped over the years in doing this study, but I'm going to leave it on my eligibility criteria for the GAIN study in case any of you have worked with young children with autism. We are still enrolling. We would love to have you. I'll be around during the break if anybody wants to speak more about it.
This question is for Dr. Abbeduto. Has the PILI interventions been used with families who speak a language other than English to help their children's language development?
It's a great question. The answer is we haven't done it yet, only because we've been limited by my lack of having knowledge of any other language. But in theory, it can be used with other families that speak other languages, and one of the things we really want to do is begin to target Spanish speakers, and so that's one of their next steps. I think the only limitation there is we also want to make sure as we move to different languages that we stay true and adapt to particular cultural practices, so that somehow we don't try and force a particular way of interacting that's not going to be kind of consistent with the culture. So I think that's a really important thing. There's a question over there, right?
Yeah. Okay.
I have a question for Dr. Hagerman. It's about the Sertraline. Are there any, or is there any data on the safety of using Sertraline in youth? I guess any long-term data?
Sertraline has some very positive effects on brain development. About 20% of those with Sertraline sometimes can get more activated. See, we want to activate language through the BDNF connections, but we don't want to activate hyperactivity. So sometimes you have to adjust the dose up or down. But those that do well and develop better language and get closer to the normal trajectory, we're following them long term. We haven't seen any long-term difficulties. We think that if you can get them on a better trajectory and kind of snap them out of the autism situation, then you have a much better outcome. But we will have longer-term outcome studies in the future.
So there's a question over here.
Also for Dr. Hagerman, I know that your research focuses primarily on Fragile X syndrome and autism, but do you think there's any applications for other disorders, primarily Down syndrome?
Yes, we have done some research on Down syndrome, and remember I talked about the GABA deficit in Fragile X and autism. In Down syndrome, it's just the opposite. There's way too much GABA stimulation. So Roche developed a new targeted treatment that was an inverse agonist, which means antagonist of the GABA pathway, and the preliminary studies were very positive. However, they did a huge international multi-center controlled trial, and it didn't demonstrate efficacy. But the problem is with huge studies is sometimes the outcome measures aren't optimal. Sometimes maybe 30% do much better, and if the rest don't do much better, that kind of dilutes out the effect of the subtype with Down syndrome. And so I think we have to do better in figuring out who's going to have the best effect, and for those that have a positive effect, go on and do further studies with them. And the NIH Toolbox has been studied with Down syndrome. You'll hear from David Hessel. Len's done work with Down syndrome, so there are targeted treatments that are being developed for Down syndrome, and you'll hear more about that in the future.
Question over here.
Hi, Dr. Hagerman. I had a question. Does sertraline have methylphenidate in it?
I'm sorry, does sertraline have what?
Methylphenidate in it?
No, no. But sertraline is one of the few SSRIs that actually stimulate the basal ganglia to improve attention and focus. It doesn't work as well as methylphenidate, but for some it can have a positive attentional effect. But you can easily combine sertraline with a stimulant like methylphenidate or Adderall or Quilivant or any of the ones that are on the market.
And you're not going to have any adverse effect if you do that, correct?
I'm sorry, I didn't quite hear that.
There will be no adverse effects if in doing that.
In combining them?
Yes.
No, no. I mean, the stimulants have their own side effects, and so you have to follow those too.
Okay.
But you know, we've had thousands of patients on an SSRI and stimulants. They work very well together, typically.
Okay, thank you very much.
Question in the very back.
Good morning. I was interested in efforts and activities that the Mind Institute is doing around physical activity for individuals with neurological disabilities, and are any of the studies that you're currently implementing engaging some physical activity intervention strategies as part of the comprehensive approach?
I recommend exercise for everybody. You know, exercise stimulates neurogenesis. If you want to make more neurons in your brain, just exercise. And that becomes even more important with aging. And there have been some studies looking at exercise. It also ups your serotonin levels. So a lot of individuals with depression, anxiety, they need to get off their tush and exercise, okay? So it helps in ADHD, helps in autism. Does anybody else want to talk about exercise?
Dr. Sam Lewis, who was a fellow here in developmental and behavioral pediatrics in the wonderful program that Dr. Hansen directs, who just graduated, performed a study looking at yoga in preschoolers who are at risk for ADHD. So they didn't necessarily have a diagnosis of ADHD, but they have high ratings of impulsivity and so forth. And the findings were very interesting. This was a very well-controlled study, and it looked like there were some selective improvements in cognitive functioning in some areas. But what was really interesting was it really depends on the modality of how you deliver it. And it turns out if you're working one-on-one with children in this category, they tend to respond well to the yoga, as well as if you're with children with these ADHD symptoms who are integrated in a traditional classroom, so they have typically developing peers as well. What doesn't work well is if you have a group of about 6 to 7 little kids with ADHD, because they all feed off of one another, right? So they have a really hard time paying attention to the poses and everything because they're looking at what their friend is doing and how to get attention and so forth. So it was a really great study because people learned as well about where it might work and where it not work. So I think it was a good pilot study, and so I'm hoping people will continue in that vein. But I see Our colleague here, Elizabeth, has a related question, perhaps?
Oh, I'm going to just add on to that. So this year at the Mine this summer, we had a small sort of pilot camp for kids with neurodevelopmental disorders. And we had yoga as a part of that weekly camp. And we're looking to add yoga some evenings, maybe once a month, twice a month, and we're looking to do some training for parents and other providers in yoga for kids in the coming year. So keep an eye out for that to happen.
But also for the parent, because the parents sometimes have a harder time controlling their emotions and how they're responding, and that affects how effective they are in terms of delivering behavioral treatment. So my fantasy is that someday we'll look at things like meditation for the parents and how does that affect their ability to respond, and can they use physiological markers like wear a Fitbit or their Apple Watch or something like that that'll note if they're having increased heart rate and so forth, and to start that feedback loop going on to help them think about doing breathing and relaxing and so forth. So that's to come.
Okay, question over here.
Thank you so much, all of you guys, for being here and answering our questions and doing such a wonderful presentation. I have several questions, but I try to ask one only. I have a child with Angelman syndrome. Metformin, would that be a good thing to go by for her, since you mentioned something about working for kids with Prader-Willis?
So in Angelman syndrome, there's some preliminary studies that gaboxidol, which is a new GABA agonist, is being studied in Angelman syndrome now. It was developed by Ovid. So this is a good GABA agonist. But you mentioned one medication you said you wanted to try?
I believe you said metformin.
Metformin.
Oh, metformin. That hasn't been studied in Angelman syndrome yet, so we don't know.
Okay.
It's not working on the GABA, it's working on that MEK-ERK pathway.
Okay.
But who knows? It might be helpful. But definitely gaboxidol, and we will start the studies of gaboxidol in Fragile X syndrome in the first quarter of next year. Mm-hmm. So we'll see about Angelman syndrome. We're waiting to see what the trials show.
Okay, thank you.
Okay, I think we have time. Okay, there's two more questions. One in the front row and one in the next to the front row.
Hi, this question is for Dr. Schweitzer. I was hoping that you would be able to elaborate a little bit more about the study you conducted in graduate school and are replicating about systematically teaching preschoolers weighting and the procedure that you used.
I'm sorry, a little bit more about
the study that you conducted in graduate school at the preschoolers and weighting.
Right. I mean, so it's a real simple concept is that we
microphone.
Thank you. We assess how long they're willing to wait. We give them different games that they can choose to play. And then we look at they're willing to wait 5 seconds to play the game, 10 seconds, 30 seconds. So we establish a baseline. And then over a period of weeks, they will be playing the game for 25 minutes. And as they, over time, what we're expecting is that they will choose to learn to wait for the longer amount of game playing. So they can maybe play a game for 5 seconds, or they could play a game for 25 seconds, but they have to wait for that longer one. And what we found, at least in the past when I did it many years ago, was that children developed their strategies on their own to learn to wait. So they tap their fingers, or they start humming or singing to themselves. The kids who were more active, they would move around and do little dances and so forth. But what I really liked about it is that they developed their own strategies. And that I was hoping is that these own strategies they could bring in different situations. So this is a very circumscribed study where it's a proof of concept to see just with this sort of mechanism, can you teach basically children to learn to wait in that context, in that more laboratory type context. But then does it generalize to the home setting, school setting, and so forth? And if we get some good results from that, that's what we'll probably look at doing is how do we then encourage parents and teachers to facilitate that sort of waiting? So it's a very simple concept, but sometimes simple is good. And it's been really fun because I had this really fantastic group of young people working in my lab who get to develop video games. That's their job. And they're enjoying it. So it's actually very technical about if there are certain games, if you play for just a little, it's actually more punishing because it's irritating to have to stop in the middle of a game. So we're looking at how you design a game and all that. And we're starting it in schools, so it's because it's just easier to recruit subjects that way. So we'll be going to preschools, kindergartens, and so forth, and where the research assistants will go there. The data will be uploaded every day to a cloud and so forth, so we'll be able to look at their progress. And then we test them after to see whether we've moved the length of time they're able to wait, and for generalization. But then we're also considering having parents take a tablet home with them. We just finished another study, which was a clinical trial where parents did take a tablet home, and the children did a race car game and a word game, and the kids loved it. Very few kids dropped out of the game, so of the study, I should say. So sorry.
So is it that they're able to earn wait time or game time for how long they've waited for?
Yes, essentially, right. Essentially, yeah.
Okay, so our last question here in the front.
Very short question. I just had a question for you doctors who study ADHD and autism, especially in relating to girls. Have you found that if a girl has already been diagnosed with a neurological disability, for instance, like cerebral palsy, does that cause a delay, or does it make it harder or take more time for them to get diagnosed with things such as autism or ADHD?
Nodding your head as well. Yes, I think without a doubt, and I think it's been really interesting to watch, is that it makes sense that the initial goal really is to increase language, mobility, and things like that. And then we get children whose needs get addressed, and they start doing fairly well. But then as they mature, and especially if they're integrated in a traditional school setting, it's the impulsivity that's causing problems, or the problems with attention, and they can't remember to turn their homework in, and they're blurting out answers in class. So we see this again and again and again. And I think we have to really start looking at, are the treatments we're potentially doing for this population may be different. So we have a really exciting project that I'm part of called ECHO. Irva Hertz-Picciotto is a PI. I'm a co-PI with Deborah Bennett. And this is a longitudinal study funded by NIH where children were recruited when they're about 2 years of age, and now they're between the ages of 8 to 12 and 15 to 19. And we have a group of children with autism, a group of children without autism, but neurodevelopmental disorders and typically developing young ones as well. And we're looking at their ADHD symptoms and how they change over time, as well as whether or not they lose their autism diagnosis and so forth. So we're going to start being able to tease apart some of that and look at the longitudinal trajectory, because I think there's so much more recognition about that overlap, and that you do need to start looking at those symptoms because they become very interfering in academic, social situations, and so on.
The UC Davis Mind Institute was created in 1998 with a promise to find cures for neurodevelopmental disorders. Every day, our physicians and researchers come closer to fulfilling that promise. Their groundbreaking research on autism, Fragile X syndrome, chromosome 22q11.2 deletion syndrome, ADHD, and other brain disorders are helping children achieve their fullest potential. Please visit our website to find out more about current studies, upcoming events, and how you can help make a difference.